Hello all, good morning. This is Dr. S. Lakshmi, an assistant professor in the Department of Mathematics, SNS College of Technology. This is a lecture video series on the course Differential Equations and Transforms, and now we are on to the topic of Laplace transforms. In the previous videos, we have seen problems on elementary transformations of Laplace transforms and the properties of Laplace transforms and the functions dealing with Laplace transforms. And we have come across all the problems and definitions there. And here we are going to find the applications of Laplace transform in ordinary mathematics. Where we are going to find the application, which means we are going to find the application of Laplace transforms in differential equations. So, in differential equations, which means an equation which involves a different derivative is called as a differential equation. We are going to solve the differential equation using Laplace transform. So, we have many other methods to solve the differential equation, but this Laplace transform will help us simplify the work to solve for the given function here. So, the results to be used for the given differential equation of second order only we are dealing with here. So, second order we are having the results here to apply in the problem. What is this? First thing, L of y dash of t. The first derivative's Laplace transform will be given by S into L of y of t minus y of 0. Y of 0 means in place of t you have to substitute 0. In a similar way, L of y double dash of t, the second derivative of y in the Laplace transform will be given by s square into L of y of t minus s into y of 0 minus y dash of 0. So for the first derivative you will have 2 terms, for the second derivative you will have 3 terms. So in the first term you will have always s term will be there. Since it is a single derivative, it starts with s power 1. Since it is a double derivative, it starts with s power 2. The first term will always contain L of y of t in both the terms, and the second term will be y of 0. S's power should be reduced, therefore s to the power 1 into y of 0. The next term is minus y dash of 0. Everywhere you will have the negative symbol only. This is how you remember the formula to find the solution of the differential equation. Now we will discuss a problem, how we will find the Laplace transforms or how we will find the solution for the differential equation. Firstly, we are asked to solve the differential equation. What is the differential equation here? It will be given here. It is a second order ODE, which means y double dash plus 5y dash plus 6y is equal to 2. As you can notice here, your RHS with only one constant, and the initial conditions are also given. What are the initial conditions? It is y of 0 is equal to 0 and y dash of 0 is also equal to 0. So we have to apply these two conditions in the results. That is why they are given with like that. To start with the solution, you have this equation to be as first equation, which is y double dash plus 5y dash plus 6y is equal to 2. Now taking Laplace on both the sides, what you have? L of the whole term is equal to L of 2. So as you can notice, it is of linear property. We can simplify or we can split up the terms in the Laplace. So L of y double dash plus 5 into L of y dash plus 6 into L of y, which is equal to L of 2. Now you can notice that it is L of y double dash, it is L of y dash. This is from the result number 2 and this is from the result number 1. You are going to substitute the result in place of L of y double dash and in place of L of y dash. Firstly, we have to substitute y double dash. What is L of y double dash? It is s square into L of y minus s into y of 0 minus y dash of 0. So that is what we have reversed here. S square into L of y minus s into y of 0 minus y dash of 0. In a similar way, plus 5 into, here you have plus 5 into L of y dash. What is L of y dash? This is s into L of y minus y of 0. That is what we have done. Here this is plus 5 into s into L of y minus y of 0. Plus what is our last term? It is 6 into L of y, 6 into L of y, and on the RHS you have 2 into L of 1. We have taken the 2 outside. So now we are going to, we have used the results and we are now going to simplify the problem. So s square into L of y of t minus s into what is y of 0? It is 0. What is y dash of 0? It is also 0. Plus 5s into L of y of t minus y of 0 is 0. We have replaced it. Plus 6 into L of y, which is equal to 2 into L of y. All the other things remains the same. Next is s square into L of y plus this will become 0, this will become 0 and that this will also become 0. Remaining terms are being implemented here plus 5s into L of y of t plus 6 into L of y of t is equal to 2 into L of y. Now we can take L of y outside from each of the terms. As you can notice, here you have L of y, here you have L of y and here you have L of y. So L of y into s square plus 5s plus 6 which is equal to 2 into 1 by s. So after this we will have this L of y to be implied to the next to the right hand side. This will become 2 divided by s into s square plus 5s plus 6 which can be factorized into s plus 2 into s plus 3 and therefore our y of t can be found using L inverse of 2 divided by s into s plus 2 into s plus 3. We will simplify this problem in the next video. Thank you.